Alright, hi you guys and welcome. Today we'll be talking about proportions and triangles and some really kind of easy stuff just to finish off this section on proportions and similarity. Okay, so first up is side splitter theorem. So in other words, if I take a line or a segment, make it parallel to one side of a triangle, okay, I actually divide this up into equal, well, not equal proportions, but proportions. Okay, so in other words, DE divided by EA is equal to BC or CB divided by BA. Okay, so in other words, if this was 6 and this was 8 and this was, let's make this 9 and this was Y, I could easily solve this by setting up my proportion as 6 divided by 8 equals 9 divided by Y. Oops, I didn't even type that. 6 divided by 8 equals 9 divided by Y. Okay, and then when I cross multiply, I should get 6Y equals 72. And then when I divide both sides by 6 there, I should get Y equals 12. Okay, which actually makes sense because 9 is 1.5 of, it's like, yeah, it's 1.5 more than 6, and so 1.5 more than 8 is going to be definitely 12. Okay, now corollary to side splitter. Now, if you could imagine drawing a triangle so big you would never see the top, the corollary to the side splitter works here when you have two transversals through three parallel lines. Okay, and I know I forgot to draw those in, but these are actually have to be parallel for this to work. Oops, let's not try to draw with the mouse. We all know how well that works. It doesn't work out too well. Okay, but just imagine if you were able to extend this for as big and forever as you need to. Okay. All right, let's make this a little bit nicer. All right, so these are all parallel, so this actually works too. I like to just say, as long as they're along the same side and you're going from one side to the other, that's totally fine. Now I know over here I usually say go from the bigger side to the smaller side. You could switch this up and have this as 8 over 6 over equals Y over 9. Okay, so the same thing here. You just set up your proportion. It's a simple, easy ratio proportion. Just something really easy. But if you could imagine them connecting somewhere up here, you could have this up there. And side splitter works. I mean, it's just, corollary is a continuation of that idea. Okay, let's go to the last theorem. It's a triangle angle bisector theorem. Okay, so in other words, if I have an angle bisector going through a side of a triangle, okay, I actually can create a proportion that I could solve and easily figure out. Okay, so what they would be CD divided by DB, okay, you have to use the same sides, would equal CA divided by BA. So you have to go from like one side to the other side. So, okay, so if we had some actual numbers, so let's say this was 12 and this was 19 and this was 21 and this was X. Okay, so now I'm going to follow my original rule, go from big to small. So 21 divided by 12 equals, okay, so 21, so CD's, okay, so that would be X divided by 19. Okay, so I do my cross multiplication. I'm going to have to check on my calculator real fast. Can't do that in my head. I wish I could. I think it's going to be, should be under 400. So 21 divided by 19. Oh, geez. 21 times 19. Yep, 399 equals 12x. Okay, and then I divide both sides by 12. I love the calculators where you can just quickly put in your information. And then x equals 33.25. Okay, and you are actually able to find this out. All right, now I know I haven't talked too much about it and stuff, but guys, you could easily flip these. Proportions are pretty nice because you can flip them as long as you do to one side as you do the other. So in other words, if I were to flip them to where the bottom was on the top and the top was on the bottom, that's totally fine. I could also switch these two. Come on, there we go, marker. I could switch these two, or I could switch those two. I just can't switch one side and only one side. If I do one, I have to do the other side and flip it as well. Okay, but I can definitely flip these two real fast, and that's just it's kind of a work of the cross multiplication postulate. Okay. All right, so when you're working with proportions, just be ready to have all kinds of crazy stuff. And if it doesn't match your answer, switch up some of these, switch diagonally, or flip both sides, and you can actually come up with another proportion that works just as well. Okay, but that's it for talking about similarity about triangles. I'll talk to you later. Bye.